So first we're going to talk about why we use databases in the first place, what the motivation is. So basically, our backend API is stateless. So what that means is that between requests, our backend does not have a permanent state by itself. And so we need some way to store data like user information, any other information that we want to be able to store permanently. And so that's where the database comes in. Now, there are many different types of databases, but one of the most common traditional types is what's called a relational database, and we'll see why it's called that in a second. And that's what we use at C4C. Specifically, we use a database called Postgres, which is actually one of the most common implementations of a relational database out there. The fortunate thing is that all relational databases are pretty similar. So by learning about Postgres, you're also going to be learning a lot about all the other types of databases, like MySQL is another common one. So this is going to be some really useful information. So a relational database is made up of any number of tables. So we might compare this to Excel, having a bunch of different sheets. It's basically one sheet, one table stores one type of data. So for example, you might have a table that stores customer info. You might have a table that stores product info, stuff like that. Now, each table contains any number of columns. So the columns are the types of data that you're storing. So if you think about an Excel file, the columns are the names basically that you have across the top of the file that tell you what the data in each column represents. Now, the table basically is comprised of a bunch of rows, which are also called entries. You can add or remove or update as many entries as you want. Now, the thing about a relational database compared to something like Excel is that every row has to follow the same exact strict structure that we give it based on the columns. So I'll give you an example here. This is a customer's table, and there's a customer ID, which is just a number, first name, which is a string, last name, which is a string, and the date created, which is a timestamp. So you see that every entry that we enter into this table has to follow this strict structure. Now, the reason why that's good for us is because it allows us to understand exactly what each row looks like before we actually see the row itself. So along the same lines, all of our columns, just like in Java, are strictly typed. So what this means is that if we try to enter a new row, if we try to update a row, every single column has to have the right data type. And if it doesn't, there's going to be an error. And so the reason this is useful for us is because we know, obviously, Java is a strictly typed language. So when we translate our rows, when we translate our entries into Java variables and Java classes, we want to know exactly the type of data that we're working with. And so this helps us do that because if you look back here, every entry has to follow that same structure. So when you add a new customer, the customer ID has to be an integer, the first name has to be a string, the last name has to be a string, and date created has to be a timestamp. So these are just some examples of data types. There are a lot of different data types out there, but these are the ones that you're going to be encountering most often. So we start off with a classic integer as well as big integer. As you might be able to tell from the name, big integer is just a much larger integer. You can store much bigger values, but for 99% of use cases, integer is going to be just fine. The serial type is basically the same as an integer. The only difference is that it's auto incrementing. So what this means is that when we enter a new row in the database, the database is going to look up the last row that it entered, and it's going to take that value and it's going to increment it by 1. And so this guarantees that every time you enter a new row, without you having to do any work, the database will increment that value for you. This is particularly useful for IDs, and we'll talk a lot more about IDs next week. But basically, an ID is just a unique number for every entry in the table. And so serial obviously helps us achieve that because every time we enter a new row, we just increment the ID by 1, and that gives us a unique new ID. Then we have the char type. So There's char of x, which basically is a string of length x. Now, the important thing here is that the char type has to have, well, is going to have that length of x. So if you enter a string that's shorter than x, it's going to be padded to be of length x with spaces. And if you enter a string that's longer than length x, the string's going to be truncated to be length x. So the difference between that and varchar, which is the next type, is that varchar only has a max length requirement. So if you enter a value that has less than length x, it's shorter than x, that string is not going to be padded with spaces. Whereas a char, if you enter that same string for a char type, it would be padded. But there still is a max length requirement on varchar. So if you enter a string that is longer than length x, it is still going to be truncated. And then we have the text type. So the text type obviously is for any string basically that you don't want to have a max length for. So if you just want to let that text be as long as the input is, then you'll use a text type, and there's no length, there's no minimum or maximum, anything like that. It's just whatever text. Obviously, char and varchar have slightly better performance than text. So if you do know something about the length of the string that you're entering, you probably want to use either a char or varchar. But if you really have no idea, then you can just go with a text. Decimal, pretty self-explanatory. That's a numeric type. Integer and decimal are basically the two types you're going to be working with in a database, in a Postgres database, that is. And timestamp is, again, pretty self-explanatory. It's just a moment in time. It has a date and a time with it. And we use this built-in timestamp type because the database, that's the database's type. So it knows how to work with it. It knows how to do some like basic arithmetic with dates. So whenever we're talking about a specific point in time, we want to use the timestamp type. And then along with that, we also have the date and time types. Date type is just a date without a time, and time is just a time without a date. So when we're making columns, sometimes these columns have certain things that we know about them. So for example, if we're making a customers column, as you saw in that example before, every customer has an ID. And so this ID is what we call a primary key. So a primary key is just the primary column that we use to refer to a specific entry in that table. And so a primary key is basically just unique and not nullable. So the value can't be null, and it has to be unique. And this makes sense because if we want a value to access each entry with in the database, we want that value to be unique. Then we have foreign key constraint. So foreign key is just a reference to another table's primary key. So for example, if we have a table that references customers, then that customer ID column is going to have the foreign key constraint. We'll talk a lot more about these key constraints next week and dive deeper into them a little bit, but it's good to have an idea of just what they are this week. So then we have not null, pretty self-explanatory. It just requires that a column is not null, that it has a value. If you don't have this constraint, you can just enter null for any column you want, but that's not really good practice. In general, we want to keep columns not null if we can, because that just enforces like a better data structure when we're working with our database. And we have auto increment. So auto increment is kind of like serial. Well, it is serial in Postgres. Auto increment is in other databases, but it's good to have an idea that exists. And Postgres has a slightly different implementation. So unfortunately, you will see these kinds of like slight differences between different relational database implementations, but Postgres is the one we're using, and it's a pretty common one. So then we have default. So default is just a default value for a column. So if you want, say, a price column to have a default price of 0, then you can set the default to 0. And every time you enter a new row, if you don't specify a value for that column, it's going to enter that default value. And then finally, we have the unique constraint, again, self-explanatory. Every value in that row, in that table has to be unique. So every entry for that particular column has to be unique. So if you want to just be sure that every customer, say, has a different name, right? You can say that the first name and the last name have to be unique. And so that way, if you try to enter a row that has the same first name and last name, you're going to get an error. So now we're going to talk a little bit about SQL, also called SQL. It stands for Structured Query Language. You've probably heard of it before, but basically SQL is the language that we use to communicate with relational databases. It is pretty much a universal language between relational databases. So again, you learn it for one relational database like Postgres, and you'll know it for pretty much any relational database that you may use in the future. It's a pretty straightforward language as far as languages go, but it can get a little complex working with, a bunch of tables and whatnot. And we'll get a lot more into the sort of nitty-gritty details next week. But for now, we'll do basically an overview of all the basic operations in SQL. So first, we have creating and deleting databases. So very simple syntax. To create a database, you just write create database and then the name. And then to delete a database, it's drop database and then the name of that database. So very simple stuff there. Now, creating a table, basically, you're going to specify the name of the table and then all the columns. So you start with create table, you write the name of the table. So in this case, the name of the table is people. And then inside parentheses, you're just going to specify every column that table has. So remember that every table has a very specific structure that every entry in that table is going to follow. So this is where we define that structure. So for example, you can see here we have an ID column, which is a serial type, and it has the primary key constraint. Then we have a name column, which is a varchar of length 50, which just means it's a max length of 50. So you can't enter a name that's longer than 50 characters. And it's not null. So not null, again, means that we can't have a null value. And again, this makes sense. We wouldn't want to have a person without a name. That doesn't make much sense. So every entry in this table has to have a name. Then we have a bio, which is a text type. And the reason we use text type is because we have no idea how long their bio is going to be. Now notice we also don't use not null for this column, and that makes sense because a user may have a bio, but they may not have a bio. And so we want to allow that null value. Next, we have the age column. That's an integer. Like obviously age is always going to be a whole number, and it's not null because again, every person has an age. It doesn't make sense for us to allow a null value there. Then we have a sign update, which is a timestamp. And notice here, we use the default of current timestamp. So all that means is that when we enter a new row in this database, we don't even have to specify the sign update. Because there's this default value of current timestamp, when we enter a new row in the database, the database is automatically going to insert the current timestamp for us. So that makes that very convenient. And then we have an enum type, and we'll talk a little bit about this later, but it's not a very common type. If you know about enums in Java, then it's basically the same idea. So now we're going to talk about CRUD. So CRUD stands for create, read, update, delete. And it's so important because these are the 4 operations that allow us really to work with data, right? So we can create data, we can read that data, we can update that data, and then when we no longer need it, we can delete it. So these are the 4 big operations that we're going to need when interacting with a database. So first we have create, and the keyword for that is called insert. So insert is what we use to just insert an entry into a table. So you can see the syntax here. We have insert into, and then the name of the table, and then the word values. And then you just basically just list the values corresponding to every column in the table, right? So if you recall, The people table had an ID. So that first entry, that 0, is an ID. And then you have the name of the person. So in this case, Jumpstart Team is the name of the person. Then you have, hey, this is a current Jumpstart Team. We're really excited you could join us. That's the bio. So that's one long string. And then the age is 0, the current timestamp, and then that's the personality type, the enum type. And now, as you can see here, you can add as many entries as you want. So you can keep just listing a bunch. There's a second entry here with the name you and a bio there and age 19. So again, you can pretty much enter as many as you want. And with every entry, you just specify all the values. Now, as you can see from this query below, some of this stuff you don't need to enter, right? So we know that the bio can be null. We know that the date, we don't have to specify because Postgres has a default for us. We also know that the ID we don't have to specify because that's auto-incrementing. So all we actually really have to write, the only two essential columns are the name and the age. So we enter those and Postgres will take care of the rest for us. So now we have the select command. So the select command is how we read. So remember our 4 operations: create, read, update, delete. Select is what we use to read data from the table. And that's why select is probably the most complicated command that we're going to talk about today. So the simplest form of select is to select asterisk, which means you're selecting all the columns from a particular table. So select asterisk from table is going to select all the entries and all their columns from a particular table and list everything out. And I'll show you an example of what that would look like on the next slide. Now you can also select only particular columns. So if you only care about the user's age, or if you only care about their name and their bio, you can just list the columns that you want to select. And you can see here the other components that make up a select. So you can use what's called a where clause, and where allows you to filter out data that's not interesting to you. So for example, if you want to only select users that are older than 10, you can do select asterisk from users or from people where the age is greater than 10. It's very simple syntax, like you can see here. You can use ands, you can use ors, basically build up any logical comparison for the entries in the table, and that allows you to only select entries that are interesting to you. So this is an example of what I was just talking about. If you select asterisk from people where age is greater than 5, you get this table here. So notice, well, actually in this case, this is a table. It has all the columns, right? Every time you make a request using SQL to Postgres, it's going to respond with some kind of table. So in this case, because you select asterisk, it's going to respond with all the columns from the people table, and it's going to respond with all the rows for which the age is greater than 5. So you see that the original entry we made, the Jumpstart team, had an age of 0, so that's not included here. So here's another example where we just select the name and the ID, and we also use this as keyword. As is just an alias. So we're just basically, instead of calling it an ID, we call it other name. And we select that from the people table. Where, so this is our where condition. And we say the name is like jump and then the %sign. So all this means is that it's basically like regular expressions, if you've ever worked with those before. It's basically you're comparing the name and you want to find a name that is of the form jump and then the %sign. The %sign, of course, is a wildcard. So that this basically just means find all the team or find all the people where their name begins with the word jump. And so that's why you see in the result, we just have one entry because only one entry in this table actually began with the word jump, and that's the Jumpstart team. So, and also you can see it just responds with the name and the ID, except the ID is called other name because we use the as keyword. So lots of different things you can do with select. And we'll get into more advanced queries next week that can really start to get a little complex and interesting. So now we have the update keyword, which basically allows you to update any entry in a table. So for example, here you can see the syntax is fairly straightforward. We update a particular table. So for example, in this case, it's table name, but it can be any table you want. And we just set a column name to a value. So we're setting, for every entry, we're setting the value of that column to whatever value we want. Now, obviously, this doesn't make a lot of sense. We're generally not going to update a table and set the values for all rows. So that's why with an update query, we're usually going to use some kind of condition, often with an ID, so we can specify an exact row to update. So if you see this last example here, we update a particular table, we set some value to, say, in this case, hello jump starters, and we'll use a where clause to specify which rows we want to update. And then finally, we have the delete statement. Very self-explanatory. It's a lot like update, except instead of updating, we're just deleting. So delete from the table name. And again, we'll usually use a condition. And this condition just allows us to specify which rows we want to delete. So if you want to delete everyone that's younger than 5 years old, we can say delete from table name where age is less than 5. And then we also have the truncate statement. So this deletes every entry in a table. Obviously, you're usually not going to use this, but it will come in handy sometimes. So this querying, the SQL language is going to be continued a lot next week. We're going to dive much further in depth with it. But for now, we're going to talk more on the server side of things, because obviously our API, our server, needs to be able to connect to the database to communicate with it using SQL. So there's going to be a good amount of code in this section. Don't worry too much about like remembering the code or even understanding 100% how it works. It's just to give you an idea of what we're doing on the Java side of things. So first of all, we have to talk about environment files. So when we're accessing databases, we often have secure credentials, right? So we might have a URL, a username, and a password, right? And of course, we don't want anyone else to know that those credentials. And the other thing is that they're probably going to differ between users. So if I have a version of the backend on my computer and you have a version of the backend on your computer, we're going to be connecting to our own local databases with our own usernames and our own passwords. And we don't want anyone else to know those credentials. So the solution is we use what's called a properties file that just allows us to specify outside of the GitHub repository. So no one else can see it. We specify any credentials that we want to set. And so we use gitignore to make sure that these files never get into the GitHub repository. So everyone has their own versions and no one knows anyone else's. And so this is basically what a properties file looks like. We'll have any entries we want. So you can see here we have the database URL, database username, and database password, and you can specify any value you want. And this just allows you to specify whatever credentials that you have. And so we're going to now use these credentials to connect to the database. So first we have to use what's called a properties loader. So the properties loader is just a class that loads our properties. So it reads the properties file and it's able to figure out what our credentials are. And then eventually we're going to connect to the database. So again, there's a good amount of code here. Don't worry about understanding what every single line is doing. This is just to give you an idea of how we're going about this process using Java. So we have this properties loader class and we have a get properties class that just gets the information that we want from a properties file. And so you see we have a public method at the bottom that gets specifically our database properties. So we can call properties loader.getDB properties, and that is going to give us all the properties in our, all the properties that are related to our database. So now we're going to use those properties to connect to the database. So this part's pretty straightforward, right? We just saw we implemented the getDB properties method. So now we can use that, take our properties, and we can get the database URL property from our list of properties, and that gives us our URL. And then we can just connect using what's called driver manager. Again, these are all classes that, well, oftentimes these classes will just be from libraries that we use. So we use driver manager and we connect using the URL, the username, and the password, and that connects us to our database, and it returns a connection type. So when we execute queries from the backend, we usually don't execute them directly. So what that means is, particularly when we have some kind of user input. So for example, if we're inserting a new entry into a table, we don't want the user to be able to enter anything they want for that column. And part of this is for security reasons. So for example, you can imagine like a user could enter a custom value for, say, a name. And what they can do is they can end the query early and start writing their own query. And it's called an SQL injection. It's a very common type of attack. And we don't want to be vulnerable to that. So that's one of the reasons why we use prepared statements. They're also just easier to write and reason about. And so basically, a prepared statement just allows us to specify the format of a query. So if you guys know of the string.format method in Java, it's basically like that. You specify all the keywords and the structure of the SQL query, but instead of putting the values that you want to enter directly in the string, you just represent them as like a question mark. And then we can one by one insert those values into the prepared statement and then call it. So here's an example of that. So again, it looks like a lot of code, but it's actually fairly simple once you take a deeper dive into it. So we start out with our query format. So you can see here we have insert into people. So we're trying to insert a new entry into the people table. And you can see we specify, right after people, we specify the columns that we're going to be entering. And we're going to, it looks like we're going to enter 2 new people. So you can see that because we have 2 entries, 2 pairs of parentheses, and we use the question mark as a wildcard. So the question mark just tells us that we are going to fill that in with a value later on down the line. So first we get the connection, the database connection using the driver manager. And then we start a prepared statement that we're going to call statement STMT. And so we just call connection.prepare statement with that SQL string that we entered earlier. And now we're ready to individually insert all the values that we want to insert. So that's what we do next. So you can see statement.setString, setInt. All these methods will allow you to enter particular values for certain columns or for the wildcards for the question marks. So you can see the first argument is just the number question mark that you're replacing. And then the second argument is the value you're replacing it with. So you can see we just go 1, 2, 3, 4. The first value is a string set to user 1. The second value is an integer set to 5. Third value is user 2, and their age is 10. So that inserts all those values for us, and then we can just call statement.execute. And we get a Boolean from that, right? True if it's a success, false if there's some kind of error. And so then we just print line. If there's an error, we also throw an exception. And then finally, we have to close the statement and the connection. You don't want to forget to do that because you can cause all sorts of leaks if you don't close your connections. So make sure to close all of that. So again, the important part here is not the code itself. You're going to have plenty of references and you're going to be able to use Google and whatnot. The idea is you just want to understand how this connection works and how the databases work. So that's it for the introduction to databases. You can see here we have a couple events coming up. One on Thursday, that's the end of semester panel with Code for a Community. And then next week we have our advanced database where we're going to take a deeper dive into the sort of inner workings of databases and how we can make the most of them. That's it.
Great job, Bill.
Yeah.
You guys learned something. If you guys want to give us a little bit of feedback, the QR code or the link, as always, will help. Connor, anything you want to say?
I guess just if anyone has any questions, I guess we can take questions right now. Didn't seem like the chat was super active today, but we're here to answer any questions you have. And other than that, I'm finishing up the care package right now, so I'll be sending all that information out probably in like an hour or two.
Awesome. If you guys have any questions, feel free to ask us. If not, thanks for coming. Hope you enjoy the rest of your Sunday.